ACAS 2020. So this session is about 1 hour. There will be one presentation on an application, and then there will be a fireside chat / a panel and a discussion with Daniel and I. So the first talk is a dual talk by Payman Mohassel and Subodh Iyengar from Facebook. They're going to talk about privacy-preserving technology in practice. So both Payman and Subodh are in the applied privacy tech team at Facebook, and they're working into applying cryptography and differential privacy to Facebook's products. So we're really glad to have them, and I'll let whoever needs to start first.
Thanks so much for introducing us, Ingrid. Let me try to share this screen. Is it visible? Yeah, the presentation screen. Yes. Excellent. Hi, nice to meet you guys. Thanks for giving us the opportunity to present in front of you guys about our work. My name is Subodh Iyengar, and I'll be co-presenting with Payman Mohassel. We're both on the applied privacy technology team at Facebook, where we lead a team of engineers that research and implement privacy-preserving technologies into products at Facebook. So our team is normally based out of Menlo Park, California, although these days we're just all based around our homes. So it's a fun experience in general. So the last 6 months to a year or so, we've made a lot of progress on privacy-preserving technology projects at Facebook. And hopefully we'll talk about the specific progress that we've made and the specific projects we've executed. But however, for today, we're going to talk about our perspective on privacy-preserving technology and why we're thinking about it at Facebook, and sort of like what the challenges we encounter while integrating privacy-preserving technologies into real-world products at Facebook. Next slide. So the classical approaches that we see in privacy, that privacy applies to products, are usually frameworks like consent and control and transparency frameworks. So usually in consent and control, an app asks a user whether or not they would consent to sharing their data, for example, like let's say a location data, and the user has an option usually of yes, or there's an option of learning more, where the user has to click through and find out more about why they might consent about for sharing this location data with a server. And once the user consents and says yes, the app potentially has the ability to collect all the location, depending on what the consent language has specified. Another framework for privacy that's usually used in applications commonly is called transparency. So in transparency, once the app has collected all this information, the app needs to provide this information to the user. And the user needs to be able to see and download all the information that the application has collected about them, either on the client or the server. So this is kind of like two common frameworks in privacy that we see applied to all the products at Facebook and sort of outside Facebook as well, and generally the industry. However, there's, in our experience, we've seen a lot of deficiencies in these frameworks. So some of these are listed here, but it can be very hard for the user to understand what the consent policies might say. There's a lot of academic research about dark patterns in industry, as well as like decision fatigue of users clicking through many different consent dialogues, and really do users understand what they're consenting for? And that's an open question that is yet to be answered. The other problem is that it can be very easy to accidentally, non-maliciously, but accidentally use the data that is collected for a particular purpose, for a different purpose. So this data might be sitting in a warehouse and it might be accidentally logged or sort of like used for a different purpose than what it was intended to in the first place. The other one is that these frameworks don't really provide any mechanism of like minimizing the amount of data that's collected. So potentially like with new security breaches that have been happening over the last decade or so of companies, the collection of data really relies on the security practices the company has around the collection of data and how it stores data. And different companies have different levels of maturity around this data. It's not completely transparent to users how the data is going to be stored and secured in the first place. So there's a lot of deficiencies in existing mechanisms of privacy, of current frameworks in privacy. So one of the frameworks that we're interested in at Facebook is privacy preserving technologies. And one of the reasons we're interested is that it augments these existing frameworks of consent control, but also provides ways of providing additional protections for this data in addition to consent and control. There are several properties that privacy preserving technologies might provide us that we are kind of interested in, and different technologies satisfy different types of these properties. For example, it might provide verifiability to end users how data is being processed inside on our servers or inside clients in itself. Like how is data being processed, and is it being processed in accordance with the way that it was consented to be collected for? We might want to use privacy preserving technology to honor privacy commitments that we're making. So when we build products, we make some privacy commitments of how we will use the data, how we'll collect the data, store the data, process the data. And we might want to honor those privacy commitments in a more robust way by encrypting data at the source or by modifying data so it's only capable of being used in this purpose. Another way, which is kind of unique of how we want to use privacy preserving technology, is to limit the access of the data to only the systems that need it. So when data comes in through Facebook, and this is not specific to Facebook, but other companies as well, it passes through thousands of different systems. And at every different system point, it might get logged or accidentally used in the wrong way. So using techniques like end-to-end encryption to encrypt the data directly from the source to only the systems that need to process the data will simplify the purpose, use, and other privacy properties quite significantly. And we're interested in how to use privacy preserving technology in that way. So techniques in PPT that we're kind of interested in are cryptography, differential privacy, secure hardware, multi-party computation. But primarily the thing to take away is we're not married to any one, we're not a research lab that's married to any one specific technology, but we're interested in applying a variety of this technology depending on the purpose that we're using it for, depending on the product, choosing the right one for the right product. And generally, we are also comfortable with like applying multiple of these in sort of tandem to serve a particular product need as well. And so another difference in our approach is that we're trying to integrate these PPTs into the existing as well as in the product development lifecycle as well, so that we can make meaningful differences in privacy and improve the honor the commitments that we're making in a more robust way, let's just say. So for now, I'll hand it over to my colleague Payman, and he'll talk a little bit more concretely on how we're using PPT to help with data minimization in Facebook. I'm going to stop sharing my screen, which is an adventure. But...
Thanks, Subodh. Let me share my. So can everyone see my slides?
Yes, it's good.
Yeah, okay. Thanks a lot, Subodh, and thank you. So let's now talk a little bit about how we're thinking about concretely using privacy preserving technology to for the data minimization purposes that Subodh was talking about, and specifically the deficiencies that we think the current way of handling data has. So a very typical scenario in any product that we build and most of the industry builds is that we collect data to provide users with some new features or new product experiences. And as Subodh mentioned, The primary risk when we do this data collection is the data can be accidentally logged in places that we were not intending to log the data. It can be used for purposes that we did not necessarily, where the collection was not intended for, and then it can lead to all kinds of other risks that comes after that happens. And then once we have this data, the data is often used for measurements, whether this is to better understand and improve the products, or to be for integrity checks, or in collaboration with partners, or to do more research using the data, and sometimes for public good, to share this data publicly and allow external researchers to use that data. So, but again, with all of those mechanisms comes risks, very similar risks, of accidentally using the data for other purposes, for data being breached, and so on. So again, there's a sharing stage where we think privacy-preserving technology can help mitigate some of those risks. So if you look at sort of the toolbox of privacy-preserving technology, at the collection side of things, we can use anonymization techniques where we say we want to strip user identities from the data being collected in the first place, so there is no actual chance of it being logged or misused later. So we can use cryptography to do that in a secure way. There is differential privacy techniques that allows us to collect only noisy data in a way that we can rigorously reason about how re-identifiable that data is. And then sometimes use encryptions or cryptographic encodings of data that limits the usage of that data by the endpoints, whether it's a backend endpoint or it's other users in the system. And then on the sharing side, often we only need to share aggregate information with partners. We can use differential privacy as a mechanism again to guarantee that the data that is shared or the queries that are made on the data has a very low likelihood of it being re-identifiable and attached to a particular user. And then more advanced techniques such as secure multi-party computation that kind of limit the data usage to very specific functions that we have agreed on, and disallow other computation on the data. So these are some of the ways we think we can really improve the current state of how collection and sharing happens across industry. Let me also then talk a little bit more specifically about some of the research ideas we have been exploring. The stuff that I'm going to talk about right now are a bit more in the sort of research stage, but they are very good learning lessons for us to better understand this technology and their limitations, and then think about how we deploy this at scale in products. And we hope to be able to talk about some of those and deployments in the future. So an example of a problem that we helped explore was in the ads space, where the idea is to be able to collect ads conversion data only for the purpose of aggregate measurement, where we don't really need to see the users' IDs. So this data is being collected anonymously, and we sort of proposed a way of making sure the data is being collected anonymously while we know it's coming from a legitimate source. So we prevent fraudulent reporting of this data using blind signatures. And this means you can actually perform the aggregate measurement with sort of the security and reliability that you expect in the current systems. So this has actually influenced some of the designs of the API designs of the platforms that provide this sort of anonymous conversion data collection. So this kind of comes at the data collection stage. Cryptography being used in particular blind signatures or or private, sort of, you can also think of this as a privacy pass. Very similar concept being used for this purpose. Another example that we have been working on is sharing data with the public for public good. The concrete example came up as part of sharing mobility data, of users' mobility data during the shelter-in-place stage of the COVID-19, and how effective policies have been, and how we can improve things, and what were the consequences. So to be able to share this data more broadly, as opposed to with a handful of researchers, we looked at differential privacy as a way of making the data not re-identifiable, and gaining more confidence that the data we're sharing publicly can be used without compromising user privacy. So that's another example that we recently worked with data teams on. And then last one that we did more recently is in doing aggregate measurements with partners, where we are using data that we have and the data that the partners have, and where there's no interest in actually sharing the user level individual data on both sides. But the idea is to be able to do these measurements to get better understandings of how certain features work, or how a product is performing. And this is where techniques based on private set intersection have been very useful. In particular, being able to do computation on intersection or joins of two data sets without learning anything else about the actual data sets. So we have designed some new variants of private joint and compute that were useful in this context. And we recently open sourced the code for that construction, and as well as a paper that's online. So it's just some of the examples that we have been exploring. While very promising, there are like obvious challenges when you sort of start thinking about deploying these at scale. And I want to point out a few of these. One of the major challenges is how we integrate these sort of techniques with the infrastructure that we have and are using, and how we make them actually meet the product requirements and power the applications that we want. Often the infrastructures are there, and we have to make sure the solution actually integrates with the infrastructure. And then the product requirements need to be met. So we have to look at our specific technology and see whether it can actually meet those requirements. The second challenge is scalability, how we can make these solutions at scale and be performant enough. Often the designs, small changes in the designs of privacy tech makes them not scalable. For example, an extra round trip can mean the solution no longer works with the current infrastructure. So you either have to think about designing a whole new infrastructure that is scalable from scratch, which is extremely hard, or to redesign the technology to work with the current structure. So this is constantly coming up as we're thinking about these solutions. Another example is the fact that this sort of privacy preserving technologies are very fragile. So even small changes to the functionality or the use case that you want to apply them to would sometimes mean you have to go back and redesign things from scratch and have to think about the consequences. And that's something that often comes up in applications and use cases where the functionality changes, and sort of extensibility of the techniques we design is very desirable. And then there is the issue of just the sheer complexity of some of the products that we need to work with. This is something that came up in Sergey's talk as well. You know, these products have been built over time, and lots of features and functionalities and have been added to them, and just handling all of those in a privacy-preserving way becomes extremely hard. So one angle is to start early during this design process And then the other is that simply we have a way to go with some of the techniques that we're building in the research community still to be able to solve these sort of charter problems at scale. And then finally, there is always this challenge of how we explain that the privacy preserving technique is actually meeting a specific policy requirements or legal requirements. How do we match the technical solution with the legal language, and how it's doing better than some of the more traditional techniques? This is always a challenge. An example is like with differential privacy. How do we reason about the fact that, you know, a differential private protected data is really meeting a specific legal requirement and explain that to regulators, but also comes up with any privacy preserving technology that we look at. And this requires both research both on the policy side as well as the technical side to make sure that both worlds meet each other in one place. And this is going to be another ongoing area of work for any team that wants to look at privacy preserving technology. Yeah, so these were some of our thoughts so far. We are really excited about the potential of privacy preserving technology. We think it's a great time to be looking at that, and we hope to be able to share more about some of our experiences and the products we're working on in the near future.
Thank you very much for the really interesting presentation. So are there any questions from the audience? Okay, so I actually have a question. How important is standardization for this privacy preserving technologies inside Facebook? Like, is it something that would help to talk to the product teams, and you know, in what form then standardization would be helpful for them, or is it something that they don't necessarily require or they don't really care about?
Subodh, go ahead.
Yeah, I can answer that question. I think sometimes it's real. I don't think it makes much of a difference to the product teams for standardization as a document itself. I think maybe what makes more of a difference in the standardization process is pointing to examples of industry-wide usage of a common pattern, and pointing to that as a example of why you should use this because other people are also using this. And kind of like those kind of things are very useful stories to tell to product teams to be able to convince them that this is the right way forward and this is not a one-off thing that people are building. As for the actual specification and things like that, it does help during implementations. It does help to be like, we're not thinking about it in a completely different way from the community. Generally, those are the kind of ways that standardization does help a lot in these kind of processes of adopting. So it does help immensely.
Thank you.
Okay, so maybe we can proceed to our last talk or panel or conversation of this session and of the workshop for this edition. Erica is also here. Hi, Omer. Hi, David. So, oh, hey, hi, Erica. Awesome. Hey. So the way we want to proceed now is that I'll just very briefly introduce you. So not to spend sort of, I'm not going to read your bios or anything. And I would like actually to ask the three of you to introduce yourselves, essentially to explain why you consider that you are in this conversation and sort of what is the background that got you here, and sort of to give an example, if you have an anecdote of, for example, where did you have to take sort of a trade-off in your career, in your path of between sort of usability, security, generality, sort of something that really highlights that challenge of creating the deployed cryptographic systems, right? So just in short, we have with us today David Archer, who's a principal scientist at Galois, Omer Shlomovits, who's a co-founder and a researcher at Kaizen Networks and Zengo, and Erica Portnoy, who is a senior staff technologist at the Electronic Frontier Foundation. So maybe let's start with Erica.
Sure. So let's see, a time when I have had a trade-off. Well, okay, so so I do a lot of policy work as well, but in my engineering role, the main work that I do is on CertBot, which is EFF's Let's Encrypt client. So we're building something that, first of all, is not meant for the general public. It's meant for the people who build websites. But the goal of having Let's Encrypt in the first place is that you shouldn't have to be a security expert on top of being a web hosting expert if you want to host a secure website. So we always have this security goal of ours primary because we're trying to make people's websites more secure. But at the same time, we want anybody to be able to use this tool. So where it starts to come into a bit of conflict between these two goals of anyone wants to use it and be as secure as you can be is when you start thinking about the kind of the long tail of the security additions that you could have. I don't know how familiar people are with the HTTPS protocols, especially as TLS versions increase over time. There's always new things that you could add, and so we want people to be able to have the ability to add on every level of security that they have. HSTS is a great example of this, right? If you have a secure website, you want it to never be insecure, and so you can set your HSTS preference so that it'll always have a secure version. But if you're just testing things out and you accidentally set that header, then if you mess something up, then you're going to have a big problem and not be able to go back. So we don't want people to be able to shoot themselves in the foot, but we want them to give them the option to do it. So there's this question of how do you roll out something like this? How do you increase it over time? And so, we tried a few various ways of doing this. We tried giving people just the explicit option to do it. That way you don't have to edit your own configuration. We'll manage that all for you. Or, a way that it'll slowly increase the length of your HSTS header over time so that you won't be stuck for too long right away with something you can't go back from. But, and I think these things are still in there. We just don't really promote them. But at the end of the day, what we realized is that if you actively know that you want something like this, it's not that much harder to just go find an example of a correct configuration. And so splitting out exactly who the user is that we're designing for. We can't build one thing that'll fit everyone across our user base in mind. So when we think about it, who are we building this for? Are we building it for the people who already know what they're doing? And if so, we really don't have to be building it because they already know what they're doing. And if we think that if you don't know what you're doing, you shouldn't be using it, then it's not really for you in the first place either. So basically, it's something that the decision was actually really just to let this go and focus on what do the users who really don't know what's going on in this world of HTTPS, what do they actually need? Turns out the things that they need are not HSTS options on the command line. They need an explanation of what is a web hosting provider and what sort of credentials do I need to get this all set up. So taking the time to focus on that instead, especially with a very small team that we have, is one of the trade-offs that we made. When you really understand who your users are, you can get them better security across the board.
Very, very interesting. I guess there are definitely follow-up questions to that. I personally have some, but maybe let's continue first with the round of sort of intro. So maybe Omer, do you want to go?
Sure. Hope that everyone can hear me. So I would like to tell the story of a project called White City. So what we wanted to do is to run a specific protocol for a specific MPC protocol. However, we wanted a very large MPC. So let's say 100 parties, okay? Now, the issue is that for this to run in the wild, we need to connect all the parties to each other. So you need to have a point-to-point, like this is like the requirement, one of the communication requirements in MPC. You need to have a point-to-point channel between each two parties. Now, the parties do not necessarily know each other. So now I have to go through this very long setup phase that even though all the achievements of the MPC protocols brings me to the point where the MPC is itself is very, very fast, the whole setup kind of misses this point and makes it very cumbersome. Now, another thing is that also during the protocol, what happens if one of those links, one of those n-square links have some glitch? So then no one knows about it, right? Only the two parties that are communicating, and now they have this fault between them. So we looked at what MPC protocols that open source are doing, and apparently all of them are kind of skipping this step, like just focusing on MPC, assuming that you have some kind of a list that holds the MPC parties' IPs or something like this, and just for the best in terms of the communication failures. So the first solution is to have like a coordinator or some kind of a central party that will run all communication through it, right? So now we lower the communication links and by introducing this middleman or this coordinator. However, now this coordinator comes, it turns out to be a single point of failure. So now if this coordinator is getting, let's say that the MPC can somehow still work, but still you can very easily DOS the entire thing by just attacking the coordinator. So then we moved into this white city model where we actually we decide to run another quorum of nodes that would run some kind of distributed computing between them. Specifically, they would run a replicated state machine, such that each one of them would hold the state, and now instead of message passing, we are updating a state. So now things I think a bit better because we can decide on the size of the quorum. We can even get some nice trade-offs in terms of the number of communication links. And what's more, we then even noticed that, so while we are solving for one specific protocol, we can make a general API out of it that could work for any MPC protocol, because this is kind of not connected to the cryptography itself. So we wrote this kind of API so that now a developer can come and or cryptographer can come with his own protocol, plug it in, and just use this communication layer.
Very, very cool, in fact. David, do you want to?
Sure. So I'm Dave Archer. I'm a principal scientist at Galva. I've been working in the space of secure computation for about 10 years now, ever since the beginning of the PROCEED program way back at DARPA. So one of the things that we've been doing over the years is trying to bring secure computation and other privacy-preserving technologies like it into firm practice. So it's been working both in MPC and FHE, working with output privacy technologies like differential privacy, then working in derivatives that seem more practical and more performant, like private set intersection, and more recently working in zero knowledge, as well as exploring how those intersect with things like hardware security, like SGX. So it's been a mix of all those things applied to a number of different places. Everything from work we did for the Bipartisan Policy Center on secure computation over county level data in Allegheny County, Pennsylvania is one example of how do we teach people enough about secure computation that we can take their data sets, have them trust that we can't see them and yet can compute on them, which is a hard sell to begin with, and then show performant and accurate results. So you get into this idea of usability versus security versus generality. Part of usability is believability. How do we sell and convince people that what we have is actually accurate when they're not experts and they'll never, frankly, understand the mathematics behind what we're doing. But other trade-offs there, so one thing that comes to mind is our work for, and Tom Fred knows all about this as well, our work for Callisto Project, a small company in Silicon Valley, focused on fighting sexual assault, sexual harassment in a variety of settings. And there was a strong need for privacy because a lot of the findings of early research showed that it was very important to be able to assure privacy of victims before they would come forward. And then we found other things. It was really interesting that victims would come forward more willingly if they knew they were not alone in accusing a particular perpetrator. But at the same time, there are all kinds of complexities around. We want to make sure that this system is bulletproof so that no one can discover either the identity of a victim or a perpetrator. So there's a ton of trade-offs there about how do we make this full system, not just one protocol or one algorithm, secure, while still making it something that's usable in a web service context. how do we then deploy things like multi-party computation to do oblivious PRF generation, for example, in that setting, while making it efficient on the one hand and not hackable or not DOSable on the other hand. So there's a ton of trade-off there we see between security and usability. At the same time, we see other major trade-offs in other places, things like the trade-off between usability and security in just programming these applications, right? How do we write code by a non-expert user who needs to write something in, let's say, MPC, like a linear secret sharing MPC, when they have really no understanding or ability to really comprehend what we're doing under the covers? How do we even have them express what must be secret and sensitive versus what isn't? And how do we use that to optimize the program and get performance out of it? So there's a huge trade-off between ease of programming and security on one hand, but ease of programming and just usability versus the generality, the algorithms we can address on the other. So that's a brief intro to a lot of opinions, I guess.
Well, thank you very much for your introduction. So something that strikes me, you know, listening to the three of you, is that a lot of discussion about this usability, like privacy trade-off, is about the tools that are available, you know. And Erica worked a lot into designing a tool that is awesome to solve the HTTPS problem for people that actually, you know, have the need of solving this problem. And it seems, you know, that Omer was describing that the tools that are out there are not fully capturing, you know, what we need in an MPC setting. And so basically, I was wondering, you know, what are the tools that you think are missing right now? Like, what would change the story, especially maybe especially in the context of, you know, multi-party computation that is not there today, but would really help towards the adoption?
So several things in mind, and one that is not directly cryptographic at all is tools to stand up and tear down and deploy these tools, these systems, right? We think a lot about how do I implement MPC correctly. What's not thought about is how do I allocate the servers by the right parties with the right privileges to make sure that non-collusion is going to happen. And then how do I connect them together automatically, because no, we can't do that by hand by a grad student every time. And so on. So that I think tools for deploying and managing are just as important as tools to create the applications themselves.
You know, it's interesting that you mentioned that have a grad student sit down and design it every time, because it's something I think about all the time. It comes up a lot in policy discussions where, you know, someone is trying to write a law that says you must implement this in a way that reveals the information but keeps it private in this other way. And I'm like, there are maybe 50 people who in the world who can write something like this, and they work for like 10 companies and they're all in this meeting right now. You know, if you write something in a way that says that every company that wants to do anything in this field requires something like that, that's just not going to be possible. Even if it's going to be mathematically possible, what at the end of the day you're going to get is something that doesn't protect privacy as well, or something that's not useful unless you have the people available for that. The way that I see the tension comes in from having these specific one-off solutions every time. What was the one? The one that Google presented at Real World Crypto a couple years ago with getting the ad data to the banks. Is my perfect example of this one, because it's something that's like relatively straightforward if you understand how MPC works in the first place, but it's not something that I would want anyone off the street just coming in and implementing. And so I go back and I watch that video and I think, how can what could we possibly do to make a system that you don't need to have a specific one-off solution that isn't, you know, open enough that it ends up being completely useless. I think there was a time when I hoped that like SGX would be that. Although I'm not sure I quite believe that anymore, you know, before all the attacks started coming out year after year and attack after attack. But like, you know, I'm not sure it's actually possible to really strike that balance of something that is a general enough system that anybody could use it, but is targeted enough. Because at the end of the day, the only way you can make something like this work is by really understanding what are the actual parts that need to be protected and what is the minimal amount of cryptography. You could just throw everything into a complete fully homomorphic encryption system and, you know, have it compute one operation every minute, right? But obviously that's not going to work. So Yeah, I without, you know, getting a general system that works across the board, I don't really know how you could have something that you could just throw into any operation. I'd be interested in hearing further thoughts along those lines from other people as well.
Yes, so I want to connect to what my fellow panelists said and put the people on top, right? So, I mean, our code is open source. All the cryptography is open source. So what happens is that there's a small but strong community around it, and there are some consumers of it. Like I see, and I'm speaking with the context of NPC at least. I'm speaking with others that are trying to use what we've built, and I think, I mean, I can probably explain it by like showing the layered structure that we are like our stack, which means that like at first you have kind of like the paper, the bare bones, where you try to stay as close as possible to the paper, and then you have another code, another library that wraps it up and try to make it more human friendly, more readable, maybe try to optimize a bit towards some engineering best practices. And then you have another layer that is more application specific and actually try to speak in the language that the application developers understand. So it's really hard to find someone that can actually go through all of those layers and understand all of them. I mean, it's not as if the like the classical modern cryptography where it's a standalone primitive that you can take using some kind of some calls from some library and be done with it, and you perfectly understand what it does, and there's a specific function that I mean, the trade-offs and the space here that you need to consider when you go into these advanced cryptography primitives is huge, and it's really hard to understand what exactly you should do and what it gets you. So and also that you are doing it in a secure way. And I see people failing doing it time after time. I mean, people coming to us try to implement or to use what we have in the community, in the GitHub, and they are just failing. They do not understand it, and they don't have the skill set to do it. So I think that the first thing that needs to happen is to kind of come up with this skill or to find those that can actually combine all of those views together, or to assemble such teams that can be examples, and then see how they work and try to copy what they do and try to automate what they do and so on.
So another thought there, and another thought that works against generality that requires tools as well is this notion that sometimes even in a strange way, even the data or the algorithm we're trying to run hugely affects the cryptographic approach. For example, I was on the phone the other day with Kim Lane talking about SEAL, talking about protocols there, and said, so Kim, can you tell me a concise way of going to figure out all the right parameters for, let's say, BFV dead air, right? I mean, does he know how to do it personally? Yes, but can you even write a tool to derive the right parameters for something like just an FHE protocol and get it right and deploy that tool to people to use it? A huge generality problem in terms of every algorithm is different. Every compilation leads to a different circuit, leads to a different set of parameters. Yet we need tools like that to enable people who are not expert programmers in crypto to be able to use these tools at all.
I wonder if it's not tools that we need. I wonder if we just need more people who understand it. Like, how hard can it really be to train it, right? Like, I wonder if it's an education problem. You know, this isn't really advanced crypto primitives and how to use them and understand all the layers. That's something you kind of have to seek out if you want to understand it. But like, yeah, I have been informed that I should not just assume that everybody understands everything and is able to understand anything. But like, I mean, the things that we teach in the levels that we have them, right? It's not like many of the things in even application development are necessarily easy. People go out and learn them. So I wonder if education, like, it's not an easy answer, it's not a quick answer. And, you know, I'm the first one to reach for the engineering tool instead of trying to deal with a human being, right? But like, I almost wonder if that's the best option that we have.
It's an interesting point. I do think that we're in a space where traditional cryptography, like you said, is more about point algorithm, if you will. I can pull this out of libsodium, I can use it. I'll probably get it wrong the first 20 times, but I can eventually learn to use it right. What we're doing with some of these advanced technologies is more of a full systems approach. So we have to train the students to be able to take on a much broader spectrum of the whole, the notion of the whole problem. And so that requires a lot of specialized training, a lot more than, say, just using AEAD out of libsodium. So I think education is a good idea, but it's going to be a huge challenge for the more advanced techniques.
Yeah, that definitely makes sense. I wanted to maybe take a branch path also on this topic, in the sense of, we've been talking about tools and about the difficulty of actually deploying and sort of the education of people. And we know that many times, you know, however much cryptography would put into a system, at the end of the day, there are flaws that are not dependent on the cryptography that could break the whole system. And sort of this is the idea of sort of the question of how much cryptography should or will replace some other sort of more cybersecurity tools, or could prevent those mistakes that are prevalent just by us being human. And maybe sort of from this, like, what other kind of business models or trends could be opened when you start using this more privacy and less security, right? I mean, I know there is a lot of in that question, but feel free to take any part of it.
I actually want to add something on top of this, is that even with, you know, the best cryptographic system, we still need, especially when we're talking about multi-party computation, or even, you know, when we're talking on like Facebook about user consent, we need a lot of legal framework around it. And we will need legal agreements between parties. We'll need legal agreement between a company and its users and things like that. And it's something that I recently found like coming more and more in my work, is that, you know, as you work on this advanced primitive, you will need to think, you know, how can I transmit this information to a person that is dealing with a legal contract, and what should be in a legal agreement in a multi-party setting.
That's a huge, I mean, we could spend hours on that combined topic alone. Hey, Daniel, so to your point about sort of, can crypto replace to some extent cybersecurity tools and practices, yeah? One thing to say is, my sense is that the two are just apples and oranges. You know, cybersecurity practice, when done right, considers full systems, and it applies frameworks like NIST RMF. And then you can think of, I think, cybersecurity approaches as building a hardened perimeter generally. On the other hand, I think of crypto applications as more of a checkerboard defense, right? We're constructing hard points and soft points throughout the system at the application level to offer defense. So I think in that sense, they're sort of apples to oranges, you know, perimeter versus checkerboard. Maybe some combination that may be the best choice, because consider, perimeter defense really didn't work out well for France in 1940. And checkerboard defenses worked well in different places throughout history. Alamein is one example, second Battle of Alamein. Frederick the Great is another example. So I think maybe some combination, but I don't see that they're replaceable pieces.
I mean, I think they definitely do have some interaction, right? You know, Signal is a great example of this. You know, you can't give over data that you don't have in the first place. So it's not like you need to protect your systems less at the end of the day, because you still need to make sure that the code that you're pushing is right. But it's just fewer things to defend. It's fewer potential targets, right? Which is going to make things easier. So, you know, even in talk right before this, right? You want the data minimization to the extent possible. That's going to make the rest of your cybersecurity tasks easier. So, I mean, I certainly do think that there's a trade-off there. I think it would be ridiculous to say it's possible to completely alleviate the need for cybersecurity, but certainly to be able to shift some of the focus is better on all fronts, right? It lets you expand your threat model a little bit, because you're both protected from the outside and the inside, which just makes things easier. And to your point about the legal framework, of course, that's just, you know, another angle that you can never give away. It's, I'm missing the name of the legal scholar right now who has the different trade-offs between the different modes of places where you can set the rules, right? But, you know, they all obviously interplay. And when you have more protection in one, you might need less in the other, but you're still going to need some, right? Because if a legal framework comes in and says you're not allowed to put in these protections in the first place, there's not much you can do to stop that from a technical perspective. So, but vice versa, you know, if the technical perspective says you can't do anything like this, and the legal framework says give me everything you have, but you don't have anything to give over, you're going to be in a better place. So I think there's definitely an interplay, and obviously I am biased towards saying that we should, you know, go hard on the cryptography front. It's just so sensible, you know. It seems the easiest way to do things, but I've also been told by the lawyers that, you know, whatever area you're in is the easiest. So, you know, from a legal perspective, they're like, oh, putting in cryptographical perspective, putting in a cryptographic protection is so hard. Why don't we just like skip that and put in some legal protections? Where I'm like, the law? I don't know what to do with that. Let me just write some cryptography and never have to worry about it. So I think it's definitely a bit of a bias, and, you know, there's nothing wrong with everybody working with the tools that they have, but I certainly do believe personally that taking the cryptographic approach is definitely one of the right ways.
You're right. No, there's this trade-off that people make where we use legal agreements instead of some kind of cryptographic assurance. So I sort of call that how do we get trust when what most people in the world want to use is its evil twin, liability. And so how do you convince a jury, or for that matter, a claims adjuster for a cybersecurity insurance policy, who's never going to understand the mathematics and assurances of cryptography, that due diligence was done? That's a hard problem.
So I want to first treat Daniel's question, and at least in my mental image, cryptography comes at a lower level than cybersecurity. Now, advanced cryptography, and all of those like MPC and then FAG and so on, kind of opens up maybe new challenges for security, for cybersecurity. I mean, it's true that under certain models you get some nice guarantees, but then you need to find a way to actually make, when you want to make like a real world system out of it, you encountered different questions that you didn't necessarily encounter when you are working with other types of cryptography. Like, let's say I'm running a two-party computation, so it's great because now I have a distributed system. However, now I have two, let's say, locations that I need to protect. I need to figure out what exactly it means, what I need to protect with each two. Not necessarily for the security, but maybe for the recovery, right? Because let's say I'm running a 2 out of 2 kind of system. So now I need to also deal with those questions. Another thing about this is let's say, it's also about for new vulnerabilities. So we recently presented at Black Hat just last week about this new type of vulnerabilities in MPC systems. But still, let's say that I have this vulnerability. Now I still need to go all the way to penetrate this, to get this access to actually be able to apply this vulnerability. So I'm saying that it definitely gives different views and I think also new challenges for cybersecurity when you try to deploy this kind of new cryptographic primitives. Now, maybe to connect it to the question about legal, so I wanted to mention the admin problem. So what's the admin problem? So again, in the context of MPC, let's say that now I'm a company selling MPC and I'm selling this, this software that's supposed to run on multiple servers of a given organization. So now what happened is now that instead of an attacker, instead of attacking a specific server, now needs to attack multiple servers. So still there's the question of, so now if I'm attacking the admin of this company, or let's say the CEO, I can still get, let's say, access to all of those servers at once. So it's really a good question how you frame it and what exactly are you trying to achieve. So let's say that now this kind of attack happened. So what do I actually say? Like, does it stand, does the model protected me? Is it what the company, the organization that bought this solution intended to, and so on. So for example, one thing that I will finish with that is, so there's MPC Alliance. This is a body of 50+ companies that are kind of pushing MPC that I co-founded. And one of the things that we are considering is to run this service of multi-party entities, and it's extremely hard to explain it legally. Like, how can you explain that now you want to run software that's going to run on multiple other companies and somehow collaborate on specific protocols? Like, there is no way to explain it in an easy way. So, but we are looking into it, and this is definitely a challenge.
So a question on, or maybe a comment on that front. It seems weird to me in some sense that if you talk about root of trust here, let's take your example of MPC and deploying it as a service. You know, typically when we talk about cryptographic assurance, we think of it as I have something that I can do in polynomial time that my adversary I can only do in exponential time. But if we take MPC as an example, you could say that, you know, at most, it's probably linearly harder to break another system and another system and another system. So if it's only linearly harder for me to break all the servers in MPC, even if they're owned by different organizations, that doesn't quite keep with the security story that we use in the rest of our assumptions about MPC. So I wonder how we actually can be convincing about that, given the world of essentially every system has to be assumed compromised or easy to compromise.
So at least, I mean, concretely, let's say that this MPC comes to protect on some kind of secret that is now distributed. So one of the tricks is to introduce this notion of time, right? So you want to refresh your security or your secrets once in a while. So you break this linearity, meaning that instead of attacking one server and then the other and then the third, you require that the attacker would attack all of them simultaneously, which makes it, I think, harder.
Yeah,
So,
I think it's worth thinking a little more about that, because this notion of persistent threats that can have been sitting idly and moving laterally for months might make that not harder. At the same time, though, if you're spinning up instances brand new for every secure computation, maybe you can rely on running with that. Yeah, it's worth thinking about more. Yeah.
thank you. That was very insightful. Maybe we would like to give the chance for the audience to ask a question or two. So does anybody have a question for our panelists?
There was a question in the chat.
So would that person want to ask that question?
Hey, can you all hear me?
Yes.
Yes.
Yeah, I mean, I was thinking from a security domain perspective. When you think of security domain, there are multiple products that you use. You use like reverse proxies, forward proxies. You use malware analysis tools. There are so many tools that are that you use to protect any organization or a systems. I mean, one thing you feel is every time you start using a new tool or a new system, you have to break the session. You have to give them your crypto keys to them. They need to analyze the data in a plain text format. One thing I feel like with the new cryptographic primitives, if we implement all these things right, there are few products that can go away, and there are few products that can just look at the like implementing, like I'm just saying, like fully homomorphic encryption, and doesn't have to. I mean, those products can go away. Like reverse proxy is one good example, and forward proxies. Those are only there for termination of sessions and to see the data in it. I hope that makes sense, but I'm just thinking in general, when we think of security, we primarily think about implementation security, but there are n number of products that surround it to protect and to provide defense and depth. Those products can go away with implementation of crypto primitives. That's what I was thinking, and I just want to hear the panelists' thoughts on about it.
Yeah, I completely agree. Like, if I understand what you are saying, so you say you can use cryptography to replace some of the security tools or not replace, but improve them. Let's say in terms of privacy, instead of seeing everything in plain, you can run some kind of analysis over ciphertext, let's say. So yeah, I completely agree that like in many other industries, the cybersecurity industry would also benefit from advanced cryptography. Yeah, sure.
So one thought about that, I think you're right that some of the cybersecurity tools might be replaceable by some of the cryptographic approaches. I think Erica had referred to the same idea earlier. One thing I'll point out though is the performance problem. We're in a space where all of these tools are so slow as to be unusable. So to think that they're going to replace things that are currently usable and performant today is a little optimistic. And we're going to have to be to the point where we can show performance of those tools that is comparable. And by comparable, I mean within a factor of maybe 2. If we start to talk about a factor of 10, and we recognize also that a lot of the secure computation today is still off by factors of hundreds to millions or so. It's a long road before we can effectively replace those tools with crypto, except in a few very specialized cases.
So maybe we can conclude with the last question from Yevgeny. Yevgeny, do you want to?
Sure, yeah, it's a little bit open-ended. So in my limited experience working with companies, I was actually amazed. I would always think that they just need like little help on some narrow problem with somebody knowing crypto, but very often it happens that some new cute question came up that at least I didn't know about, and several times it led to actually research papers, which was super excited, but I just stumbled upon this by luck. So in your experience, how often do you just want to solve something and some cool thing happens to the best of your knowledge? There is no paper at Crypto, Eurocrypto, there is no standard solution. You would actually benefit from somebody from maybe more traditional Crypto, Eurocrypto community. And if you agree with that, what's the best way to reach out? Because we would love to know about such problems.
Yeah, I think it's a really interesting question because it's about how do you, when you run into these problems, how do you make the community aware that, this would be something to solve? And I think right now it's not super clear. Like there are researchers in the industry that come to this problem and are going to do the research, but it's not necessarily shared more broadly. So what would be a good way to convey this research problem?
And maybe here I can add just the topic of community and open source community as a whole, which we didn't get a chance to talk about, but it's sort of this idea of how do academics interact with open source community and developers and sort of create this influx of information.
Well, so actually I kind of want to complicate this a little before we get too excited about this concept, because I do sometimes see things like this. And unfortunately, they usually happen when there is a problem that a lawmaker has decided that needs to be solved and has decided that the crypto community will just be able to solve that. And so wants to say you must solve this before actually having an answer or even proving that it's possible to be solved in the first place. And often my first reaction to things like this is, how about we don't legislate that this is required before going ahead and doing things? And so when people jump up and say, hey, great, look, I found this source of a problem. We could totally solve that. Let me start coming up with some drafts, and maybe 10 years down the line, we'll get something standardized out of this, right? But that's a little worrying to me because, you might not, and it might never be as performant as you need it to be. But what the lawmakers will always hear every time is, great, this is technically possible. It is feasible to do this. Let's require it to be done. And that's not always the solution that we want to see happen, and is often not the case. In fact, we would rather often that they say, let's not make this a requirement. Maybe let's say we need to study it for a bit. And so I think that for some of so I would recommend looking at, what people want to legislate to solve problems with and looking for those as solutions. But I think it's really necessary that if you do go look in that avenue, the absolute #1 first thing to do is to make it extremely clear the difference between, a crypto paper and an actually implemented solution, which is not a distinction that lawmakers understand most of the time. Just for one example that I've been dealing with recently, there's this, Brazil wants to require traceability. and the way that they're going about this is absurd and is not reasonable at all. And maybe there is a way to do this in a privacy preserving way without revealing more information than is currently done. But what's going to happen at the end of the day is the lawmaker, if we don't stop this, is that the lawmakers will instead say, great, you know, this is just, it has to be done. You have to implement this. We don't care whether it's privacy preserving or not. It needs to be implemented, especially if they believe that there is a privacy preserving way to do it. And then at the end of the day, what you end up with something implemented is something that is just worse across the board. It doesn't preserve privacy. Given that it's already been implemented in a non-privacy preserving way, the need to have a interesting crypto problem to solve goes away, because once it's already implemented, you already have that slippage. And now nobody wants to build on a protection for functionality that already exists. So, you know, although that actually kind of leads into the second thing that I would look at, which is to say that places where we already kind of accept the privacy protective, the privacy non-protective version of things that's already been out there and implemented, and say, can we do this but in a privacy preserving way? And it seems almost as if, why bother? It's already fine if it's implemented like this, but it's one of those ways that we could just take back some of those protections that we lose through situations like this.
I think you're exactly right, Eric, about that last point, that if it's already done today, and there's no privacy preserving, sprinkling privacy on top is not going to interest people and not going to change the way things are done, right? If we don't need it today, why do we need it tomorrow? There's no driver there. And we know that the public in general don't care enough about their own privacy, witness any privacy policy that you sign up for every day on the web, that they're not going to force the issue with Congress or other legislative bodies.
I want to first to thank Evgeny for this question. Second, to say that yeah, this is completely the case. I mean, in my work, I encounter this what you call gems all the time, and there's so many clean questions, at least that I see. I mean, some of them may not become, you know, a research topic. Some of them would start as a research question, but then would turn out to be something a bit different, which is also fine for me as someone from the industry, because we are kind of pushing forward the space, right? So having some researchers from academia looking at some environment or some problem is good for me, even if it's not the specific problem that would answer my need at this specific time. But still, there's many good questions that we encountered. Now, it's really important that, I mean, again, for us, we are open source and it includes the research. So it's really easy for us to communicate those problems the moment we find them and we decide that they are good. And then we just go to academia. We also, I mean, putting on my hat as a researcher, one of our goals is to work on beautiful problems, right? On problems that are fun to work, that are that would be happy to work on. So the moment you approach a researcher that and then you pitch him this problem, and he says, "Look, this is an interesting problem. I want to work on it." And if by chance he has the resources or the students to work on it at some point, so it's okay. So you actually do it. You know, it might take a little longer than it would actually take usually to solve problems in industry. Again, it might not be complete fit to what you are actually looking, but it works. Like I can name a bunch of papers from the last couple of years that are joint work with academia that we've done on specific problems. Right now, I'm working on a problem about which is similar to broadcast encryption, but harder to do. And I think it's one of the most interesting problems I found. And the minute you pitch it to someone from industry, from academia, they understand it, and yeah, and this is how projects are being made.
So thank you very much, David. I would love you to hear your answer. I just feel like we need to be mindful of everyone. We're already sort of 10 minutes over, and we're also getting pinged by the other organizers. Please, David, feel free to answer, to put your points also on the chat, or maybe we can create a different thread at some point. I want to, first of all, again, thank our panelists, David, Omer, and Erica. Thank you so much. This was a super interesting conversation. I hope you all got some meaningful aspects out of it as well. Thank you again, to everyone for attending, to all of our speakers. This is the second edition of the ACAS workshop, and we're excited to say that we think that it's been successful to get 50 people, 60 people all throughout the workshop on a Saturday is definitely an achievement in our eyes. We encourage you to send us feedback or to tell us what you thought about the talks and about the content. We would very much appreciate it, and we hope to see you next time. I guess enjoy the rest of the crypto conference as well. So thank you, everyone.
Thank you, everyone. Goodbye.
Bye. Thank you, Kay, by the way.
Yes.
Sorry, I didn't mention it before.
Sorry to put the brakes on.
No, absolutely not.
Kay and I have been working together. I just wanted to say, if you have any feedback on
Wait, you may want to stop the recording. Sorry.
Oh gosh, yes. God, sorry.